So in this video, we're going to be talking about the different ways you can collect data from people or from subjects to find out information. So I wanted to start with this example that kind of shows you 3 different ways to collect data about the same thing. So let's say you're interested in finding out what proportion of the population likes rock music. So you think about 3 different ways you could go about this. 1, you could pick a random sample of people and just ask them straight out, do you like rock music? And record what they say. You could pick a random sample of people and follow them for a period of time, and then kind of pay attention to what they're buying as far as music goes in stores, online. And then finally, you could pick a random sample of people, separate them into groups, and have each group listen to a different genre of music, and then collect data on the people who display an emotional response to the rock music. So who act like they're really enjoying when they listen to the rock music. Okay, so just right now we're just really talking about what these 3 methods are and how they're different and similar. So when we think about how they're similar, well, they're similar in that you're going to find out something about how these people feel about rock music. And what I did notice that's similar is in all of them we do talk about finding a random sample, meaning you're not just doing what's convenient and asking your friends or whoever's nearby, you're taking random people. But there's definitely differences in the way they're collecting it. So in part A, this is something that would be pretty easy to do. You're just asking a question, so that's one way to get data really fast. B would take a little bit more time because you're following people around and noting what they're doing and their habits. And C, again, still going to take some time, but this is a little bit more scientific in nature. You're putting people into groups and having them listen to different kinds of music. So B and C certainly are going to be more time consuming, and I think C would be a little bit more scientific than B. So just something to think about. And now what I want to do is give you some names for these 3 examples of ways you can collect data. Okay, so the types of statistical studies that we're going to talk about are observational studies, surveys, and experiments. So technically an observational study is really a larger category. This would just be something where you're recording something for the people in your sample. So in an observational study, you're usually just observing subjects as they are, and you're not manipulating them, meaning you're not changing anything about them, you're not putting them in a certain setting, you're just observing them. Now, if we get more specific with an observational study, a survey is a very popular type. This is where you just ask people questions. So if we think back to that example we were looking at before, just asking people, do you like rock music? This would not only be an observational study, but more specifically, we would call this a survey. So technically a survey is a type of observational study, but it's a more specific way to identify it. And finally, an experiment is kind of what it sounds like. This is where you assign subjects to treatments to see what effect the treatments have on some characteristic of the subject. So this would be like that example from the last slide that said you put people in groups and have them listen to music and you watch how they react. So an experiment means you're always assigning them to certain treatments and then seeing what happens and noting any changes or how the people react to the treatments you've given. So those are the different types of studies. So what we'll do now is we'll look at some examples. Okay, so for each of these, you're going to identify whether it's a survey, an observational study, or an experiment, and then we're going to give a reason. We're going to be a little bit more specific on a couple of them. So if it's an observational study, we're going to identify the population of interest. So that really just means who are the people they're actually trying to find something out about. And then for an experiment, we're going to identify what are called the treatment and response variables, which I'll explain when we get to an example of an experiment. So number 1 says a study investigated whether boys are quicker at learning video games than girls. 20 randomly selected boys and 20 randomly selected girls played a game that they had never played before, and the time it took them to reach a certain level of expertise was recorded. Okay, so because they randomly selected people, had them play a game, and then just watched, so this whole idea that the time it took them to reach a certain level was recorded means they didn't do anything, they didn't interfere. This would just be an observational study. So that means then we have to identify the population of interest. So if we think about what this study is really after, they're investigating whether boys are quicker at learning video games than girls. So that means our population here, it wouldn't be kids that aren't interested in video games at all, because why would we care? The population would be boys and girls who are interested in video games. Those are the people they really want to know, who's learning faster. That's something that's interesting to them if they're making video games. Okay, number 2. As your statistics project, you collect data by posting 5 questions on poster board or on your classroom and recording how your classmates respond to them. Okay, so while this is still technically observational, because there are questions involved, anytime you're asking people questions, that becomes now a survey. So again, while you're still not manipulating or giving any kind of treatment that would make it an experiment, it does fall under the heading of observational study, but it's more specifically a survey because of the questions. And there was nothing more specific we were supposed to do for a survey. So we'll go on to the next example. Okay, a professional sports team traded its best player. The local television station wanted to find out what the fans thought of the trade. At the beginning of the evening news program, they asked viewers to call one number if they favored the trade and a different number if they were opposed to the trade. At the end of the news program, they announced that 53.7% of callers favored the trade. Okay, so this was a radio station or a program asking people to call in, and since they didn't do anything to influence anybody's opinion, they really just posted a question to the viewers and then had them call in. This would also be considered a survey. So it's not a survey in the traditional sense of walking up to someone and asking a question. It's happening on a show, but it's still asking something to the audience and having them respond. So that would be a survey. Number 4 says the local Department of Transportation is responsible for maintaining lane and edge lines on its paved roads. There are 2 new paint products on the market. 20 comparable stretches of road are identified. Paint A is randomly assigned to 10 of the stretches of road, and paint B is assigned to the other 10. The department finds that paint B lasts longer. Okay, so you've got 20 stretches of road. They're randomly assigned to 2 groups, and then they're administered different paints. This would be a great example of an experiment. Divided into groups, given some kind of treatment or something like that. So it did say for experiment that we're going to identify the treatment and the response variable. So in this case, the treatment, what did they do to the roads? They gave them paint. So this would be paint A or paint B. And so the response was finding out how long they lasted. So in this case, the response, how long the paint lasted. Okay, so you've seen an example of all the different kinds of studies. Okay, so we're going to talk a little bit more. Okay, so now we're just going to quickly talk about ways you can eliminate bias with each of these different types of studies. So what this paragraph is just talking about that when you take a survey, you want to be careful how the survey participants are chosen. So I'm going to kind of skip down here to this example. So there was a case in 1936. So the Literary Digest, which is a magazine, predicted that this guy named Alf Landon would beat incumbent President Franklin Delano Roosevelt by 370 to 161 in the Electoral College, and Roosevelt ended up winning 523 votes to 8. So clearly something was really off. So they do tell us a little bit about how the questionnaires were sent out to people. They selected them from these lists, from the magazine subscription, from automobile registration lists, phone lists, and club membership lists. Over 2 million were returned, and you would think that this would have represented a large amount of the population since it was such a large sample. So what's the problem here? Okay, well maybe the people on these lists tended to vote a certain way or they were affiliated with a certain political party. So in this case, they really should have been more random in how they selected the people. So in this case, I think the problem being the way they chose people. Maybe these lists themselves were biased. So if you're getting all of your people from the same types of groups, that can end up being a problem. So we want to worry about the same kind of thing in an experiment. So here's an example. We're talking about how important random assignment is so that you're making sure that the comparisons that you're making about the treatments make sense. So for example, a university biologist wants to compare the effects of 2 weed killers on pansies, which are a type of flower. She chooses 24 plants. She applies weed killer A to the 12 healthiest plants and B to the remaining 12 plants. So she's not going to know which plants died due to the type of weed killer she used and which ones were already on their last legs. So if she had randomly selected 12 plants to receive the weed killer A and then the rest to B, this would make sure that she was getting something fair. So I think this makes sense. If you're being biased about the way you're assigning the 2 treatments, then the results that you get can't really be used because there's already some bias that's sort of built in. So this is just an example of, again, why random selection well, actually in this case, random assignment really being more important. Random assignment of the subjects is so important. So just a couple of examples of ways you can have bias in your studies.